Hey guys, my name is Felix for Kurniawan, and today we'll talk about the hashing techniques, or more like the how to make a good hash formulas, and I'll also talk about the common ones. So let's get started. It's quite an easy topic compared to RBT, so I believe you guys can understand well. So what makes a good hash functions? First, easy to compute. Why? Because if the hash function itself is an algorithm, or like if it's long and it's tedious to do, then it will reduce the efficiency of the hash table itself. So we want it simple, short, but let's see what are properties. We want it to distribute keys equally into the table. What does it mean? So if I have a hash function and its key will only be distributed to, like, for instance, allowed to the tree, so data will be inputted to the same position. It will create this thing called collision, and in some cases when we do not anticipate this collision, the data can be overwrite. So it's overwritten, the data can be overwritten, sorry, so data will be overwritten, and that's a catastrophic event. Data can be replaced, it is lost, and so on and so forth. So you want the data to be distributed equally in the size of the hash table. All right. Next, yes, as we've said before, we want it to distribute equally because we want less collision of data in the hash table. So, as I've said before, when we have a key, we use a hash function to convert it into hash code, and the hash code will map the items or the data into the hash table. We want it to be distributed equally so that we want to maximize the space used. So we want a function that can distribute it equally, and those kind of function usually involve modulo. Why? Because the result will have great varieties. Instead of, for instance, if you want to create a function which only says like the x as a key, the hash function will only result in 1, let's say. It's all right, it's totally a hash function, but its efficiency is reduced to just inputting one data into the same place over and again, and it will overwrite the data and it'll be bad. So if I said it's all right, it means that it's a hash function, but it's a bad hash function. So what you want to do, there's this thing called modular hashing, meaning that the hash code is equal to the key and operated with a module operator with a certain number n. So we have this thing called modular hashing, meaning that there's a hash code equals to the key operated under the module operator by a certain number n. And why modulo? Let's see. So if I have a certain number, let's pick a number. What will it be? 7 maybe? 7. So let's operate 0 modulo 7, which is 0, 1 modulo 7, 1, 2 modulo 7, which is 2, and so on and so forth. We will figure out that it will have a great variety, which it has actually 7 variety of answers, which only 0 until 6, because 6 modulo 7 is actually 6, and 7 modulo 7 is actually 0, and it will repeat the cycle, so it has great variety of answers. So this is a very common and very basic hashing method, which is called a modular hashing. So if I have this key and I perform a modulo of 7 and it results to 0, then I will map the data into the 0 position in an array. So yeah, that's modular hashing. Next, we have a mid-square method. What is a mid-square method? Mid-square method is a method where you square the key, you take the middle part of the key squared, as many as the number of digits of the original key, and if key squared is not equal in a sense, add 0 padding on the left. What does it mean? So if, let's say, give me a number, I'll take number 765 maybe, and this is my key. So this is the key. I will square the key. What's the answer to the square? Let me grab a calculator. And the answer is 585,225. So what do I want to do with this number, this squared number? I take the middle part as many as the number of digits of the original key. So how many digits do we have here? 3, right? 3 digits. And I want this to have a middle number, meaning that I have an equal left and right number, but apparently I can't, because if I take 3 numbers in any point of this squared number, I will have different numbers on its left and on its right. So what do I do? If key squared is not equal, quote unquote, add 0 padding on the left. So I add on the left here. Can we take a number? Take 3 number? Yes. So we have 3 number here, 2 numbers on the left, 2 numbers on the right, and here we go. This is our key. Key that has been processed into a hash number or a hash code. So this is our hash code. Okay, that's easy. So next we have the digit sum. And we first decide how many numbers n do we want to group together the key. Next, the group n numbers from the right and sum them up. So what does it mean? It's fairly simple, as usual. I believe in you guys. Let's take a number 76,252, for instance, and our n will be 2. So what do? I group 2 numbers 2 by 2 from the right. So 2 numbers here, 2 numbers here, and if there's no 2 number here, I can like add 0 and I sum them up. So I want the sum of 7 plus 62 plus 52, and that would be 11 plus 60 plus 50, it'd be 121. So as you can see, I still end up with a 3-digit number, but I have decided that my n should be 2. So what do? I would group again 2 by 2 numbers. So it's 1 plus 21 equal to 22. So this is my hash code. So what do I want to decide from this hash code is, when you decide the hash code, make sure that the function will always return the same hash code from the key given. Yeah, that's it basically. That's how you make a hash code, and that's the properties of the a good hash code, and some of the basic hash functions that you can use in creating a hash code. So yeah, see you guys in the next video. I will try to explain about how to prevent collision, because inadvertently, when you have a hash function, you cannot create a perfect hash function. Well, you can actually, by spewing out the output just the same as the input. Therefore, you can create a different and distinct hash codes. However, that's not the point of hash tables, right? So we want it to be efficient, yet we want it to be quite distributed in the hash tables, in the sense that we do not want clustering of data and so on and so forth. So yeah, I will talk about the collision of data in the next video, and see you guys. Peace.